All right, it's 12:30, and so here we are. This is yet another attempt to do another lighting demo. This one's going to be live, so we're going to play with it as we go. So the title of the course, or the title of the webinar today, is Light Distribution Using Ecosense Trov. And so the goal here is to walk through different lighting distributions and how they affect architecture and displaying architecture. So what I have lit up behind me, I'll get out of the way so you can see it, is the Trov L35. And this is in a 120-degree distribution, right? So very nice and broad. And I'm going to pull the camera into the room so you can sort of see what it's doing up on the ceiling here. But what you're going to see is it's a 120-degree, very wide lateral distribution, very soft distribution. The goal of this distribution is basically general illumination in a cove application. So the typical orientation for that would be to lay the fixture straight up. You're going to get back spill into the cove and then forward throw out onto the ceiling. That's the idea. It's a soft light. It's not meant to be asymmetric. It's not meant to get light across the ceiling. It's meant to light the space openly, right? So I'm going to pick you guys up. Over. Forgive my shed setup. I'm still working out some of the details there. But looking up on here, Ecosense is a really cool product for this because Ecosense offers on the order of 20 different optics with their L50 product. So the L35 is interior only and always going to be 120 degrees. However, you'll see in these next distributions that they actually offer several other optics, right? So the one that I'm going to light up next is the 60 by 40 optic. 60 by 40. So if you're looking at the fixture, I'll grab this one as an example. When we say 60 by 40, if this is the fixture, we're talking about 60 by 40 laterally, okay? So as you're drawing out that beam application, okay? So 60 by 40 beam application. This one is the 60 by 40. This is something else I'll show you in a second. So I'll unplug this guy and light this one up for you. And you can see that this is a little bit punchier, right? The camera may not pick this up, but I'm going to take you over here and actually just show you live. I'll pick you up and show you. So as you come in real close to the light source here, there's your 60 by 40. And as I back out and the camera adjusts, you can really start to see that this is going to get light more broadly out into the space. As I back off of here and pull this camera around, now you're looking up at the light source. And you can see how broad that 60 by 40 is, and it's punching more light forward than the 120 degrees. It might be useful to show you that in comparison. But that's a 60 by 40 optic. So where would you use a 60 by 40 optic, right? This is the thing that we want to keep coming back to as we discuss this, is what are the appropriate applications for these different beam spreads. So a 120 degree optic is a cove lighting optic, right? It's really meant for everyday interior cove applications where you're just trying to create a soft pocket of light that both lights the sidewall of the pocket and out over the ceiling. 60 by 40 or a wash optic like that is meant to push a little more light toward a target, but not give you a lot of optimal spill or not optimal spill light, okay? So there's a couple of different differences there in how you might want to approach it. Moving over now to the asymmetric optic. So Ecosense developed a while ago an asymmetric optic. Now the goal of the asymmetric optic is a little different. And again, the camera is going to do its best here, and we'll work on better optics for the camera in future presentations, but I'll get it real close, let the camera adjust, and then back out a little bit. Now the difference that you're going to see with an asymmetric optic is that rather than, you can actually sort of see the line of light that it's going to create. So rather than creating a spill light that's direct, right? So with a symmetric optic like the 60 by 40, 30 degrees out from nadir is going to create as much light above the fixture as it does below the fixture. Asymmetric lighting is different. So it's going to throw the optimal amount of light closer to the ceiling with just a little bit of spill light kicking out down here. The idea there is that you're going to get an optic sort of like this. As I pull back, you can sort of see what that's doing. So rather than that 60 degree optic, so if I push this out toward the ceiling here, if you remember, that 60 by 40 was really punching the ceiling out there. The asymmetric is more grazing out over the entirety of that ceiling, right? Nice and sort of open in the loft. So that's the 60 by 40, the 60 by 40 versus the asymmetric optic. Where do you use an asymmetric optic? So asymmetric lighting is actually coming back into style. There was a period of time where that was the way to light things. When you think about asymmetric lighting, the thing to think about are what usually comes to mind for people are like atriums or airports or large domed spaces where you're trying to push light far across. So if the vertical is here and the fixture is here, you're really trying to get the majority of the light out that way and just a little bit of light up the vertical. So that's the main purpose of an asymmetric. So if you're doing a space where you're trying to eliminate glare but create a horizontal plane that's luminous, that's where you're going to use asymmetric lighting. And you can put any of these in a cove pocket and aim them properly to get that effect. And there'll be more in the blog post as this that this will be attached to show that. All right. So that's the asymmetric optic. What's the opposite of all that? So, I shouldn't say opposite. What's the difference of all that? Give me 1 second here. My door is drifted open, so I have some more still light than I want. If I get this wedge this closed. So as I look up against this wall here, the idea is going to be to show you some different grazing optics. The first one I'm going to show you is actually a 70 by 70, which is a slight variation on the 60-40 that I showed, but I want to have this loose and open. I can show you how the fixture is meant to work. So when I say 70 by 70, what I mean, and you can see this up against the wall really clearly. If I get this up here like that, you can see a 70-degree beam of light. And then if I get it laterally against the wall, you're also going to see 70 degrees outward from the fixture, right? So really, really useful. I'm going to grab this and come on a little closer so you can really see what I'm talking about. So if I get that in there, there's that 70 degree. And you can really see the cutoff on the 70 degree. Very, very clean. And then if I come out here, the camera really does pick up that line of light. That 70-degree cutoff coming out of the fixture. So again, similar to the 60-40, what am I using that 70 degrees for? If I turn out and I show you the ceiling plane, you like that? That's my light, my current light blocking situation. But if I get out over the ceiling like that, you can start to see what that light's going to do. There's a sharp cutoff line. I can aim it at a target, and I'm not going to get any further than that. So if all I'm trying to do is light the ceiling, or in a downlighting application, I'm just trying to light one panel or one pocket. I'll come out this way and show you what I mean. With a little bit of outlight, but not too much. There's the floor. That's the purpose of a 70 by 70 optic. Really just fun to play with, right? Like the idea that you have these different optics can really, really change the dynamic of the space. I'm going to pop this one out, and then we're going to move over to grazers, okay? Grazing optics are one of the most fun optics to work with if you've got textured surfaces. So think of feature walls, rock walls, anything that has a texture that you want to bring out versus something that you want to flatten. Wash lights, like the 70 by 70 I showed you, or the 60 by 40, are going to flatten texture, okay? Which might be the goal. You may have a piece of art, or you may have a wall that a gyp wall that you don't necessarily want to pull out the bubbles and the ripples in the gypsum. You want to just have a nice softly lit asymmetric wall, a nice bright luminous wall without a lot of texture. But if you want to highlight texture, if you want to show what these things are doing, then I'm going to go right here and light up. This is the 9 by 29 optic, which is probably the most popular grazer, at least for my customers. This is the one that gets specified the most often, and there's a pretty good reason why. So when I say 9 degrees, again, I'm going to turn this to the wall so you can see. See that laser beam of light coming out of the fixture? Right? Now I know that the quality of the video is not necessarily where we want it to be, but you can get that sense for how tight that beam is vertically, right? Now if I get this up against the wall, you'll also see the 29 degrees. So it's much tighter than that 70 by 70. Instead of getting that lateral throw, it's tighter to the end of the wash, right? Why do I want that? So you're going to see with the next example, sometimes I want the lateral spill and sometimes I don't. In this case, if I want to be really tight to my pocket without wasting any light laterally. And I don't want to, like maybe there's a window here and an adjacent wall. So I'll give you an example. If I was grazing a feature wall outside and I didn't want too much exterior, too much of this light spilling into the adjacent window, then I would spec a 9x29. So that's going to keep it a little tighter. If, on the other hand, I want that lateral spill, why do I want the lateral spill? So one case I don't want it, the other case I do. Why would I want it in one and not the other? Let's say, for example, we are doing a facade wall and we want to minimize cost. So we have some depth in our cove pocket and we can spread that light out. Now I can go to the 9x59 optic, which is just a little broader. So the next fixture over can actually have a little bit of a gap and you're not going to get any sort of shadowing down in here, right? Which is a nice option if you're trying to either minimize cost or you just want to ensure that you're going to have a really, really soft bottom line of the cove pocket. What you're looking at, of course, are these just out in space. But that's never the way they're actually intended to be used. I'm going to set you up right here so you can see this. Let me get you set. You can see what my intent is here. So again, 9x59 optic, if I take this little piece of black board here and I put this in as intended, now you're going to see a couple of things. All of the spill light that's coming off the lens, you can actually see up on the ceiling above, goes away once this is in a proper cove pocket. This is the kind of installation detail that is expected for something like an Ecosense or any kind of grazing optic. You're going to put this behind something. And once you put it behind something, two things happen. One, you can see what's happening on the ceiling, right? Two, the defined line of light here becomes very clear, right? And so the next fixture over fills in that gap and gives you a nice even pocket of light as you go up, all right? So it's very simple to do, very simple to achieve the kind of asymmetric lighting, or in this case, grazing optic that we're looking to do. And I'll show you real quick. The Trov fixture, what I really like about it, beyond all the other, feature benefits of it, is I love the line voltage, and I love that these just plug straight through. You're going to see, this is how your contractor installs this, by the way. They simply plug in one into the other, 1 foot and 4 foot lengths. And now that you see these come together, you can sort of see what I'm talking about. So if you look at the far end of this one here, I'm just going to be wide enough that I can sort of show you. Maybe not. Here. You know what I can use? Grab this. Put these next to each other. So if I hold these up for you, you can sort of see what I'm talking about. If I hide this in here behind the nice blocker, just like that, what you're going to start to see is what I meant by that cutoff. So over here, I'm lighting this piece of wood here, this edge, and you can see that lateral spill, right? But if I come over here, that spill is cut off. I'm not lighting this nearly as much. So once I put this in a proper cove pocket, the fixtures sort of disappear, and you get a nice graze of light right up the wall. Really nice detail. Now, this is a textured wall, and you can I'll post some stills once the webinar is over. I'll take some take some pictures of these, and you can sort of see what I mean by bringing out the grazing. The last thing I'm going to show you as part of this demo is what happens when we use the cove pocket in relationship to something like the L35. Oh, I'm sorry, forgive the view, sorry. One thing that I will show you here, let me back this out so you're not looking directly at my belly. If I light this up for you, like that, and I clip this out like that, I'm going to just show what happens when you get this in a proper pocket as well. So again, hiding this up here like that, and how you build out that pocket is going to determine how that light distributes. That front fence of the cove is really what matters here. The more space you give that 120 degrees to play, the more light is going to come out of the ceiling, right? It's a very simple concept, but a lot of designers miss this. They miss that the architecture of the cove is what's going to allow the light to travel. If I come all the way down to here, I still block your view of the fixture, but I get the maximum amount of light out. If I start to raise that fence, I'm going to start to cut that light off earlier and earlier. It's a very simple detail to draw. If you're ever drawing a section sketch, Simply draw a 120-degree cone or triangle coming out of the top of the fixture. When you do that, and then you raise the fence in front of it, you'll be able to project out where that light's going to get cut off. It's a very simple thing to do. Lastly, I'm going to show you what happens when you use a dedicated optic. So if 120 degrees gets cut off by your fence, or what I'm calling the fence, the front edge of your cove, using a punchier 60 by 40 optic and grabbing this like that, you can see I can hide the fixture completely and not affect the light coming out of it, right? I'm standing at 5'9", and you can see that I'm missing this completely, but the ceiling is lit up. So that kind of walks through some of these cove lighting applications, some of these demonstrations. We're in a weird, crazy time in the world right now. And so this is my attempt at trying to provide some interesting content across different lighting concepts for architects and for lighting designers and engineers. If there's topic ideas you have, questions you have, you can reach out and we can we can always do more stuff here in the shed. I've got more stuff and I can always get more stuff from my partner factories. So thanks very much for joining. And if there's anything else I can do, let me know.